Hello students, in today's session we will deal with network topology. Before discussing in details, let's see what is a topology. Topology means arrangement of computers. We all know network is an interconnection of computers, and the topology reveals the physical structure of that network. Now let us see different types of topology. First one, bus topology. Second one, star topology. Third one, mesh topology. And fourth one, ring topology. So these are different types of topology. The difference among this is the only difference in arrangement. There is a common factor in bus, star, mesh and ring, which is it connects the computers in a network, and it also offers data sharing as well as resource sharing. The only difference among them is the arrangement of computers in that network. Now let us see these topologies one by one. First one is bus topology. In bus topology, there is a central communication cable which is known as bus. That's why its name comes as bus topology. And in bus topology, every computer system is connected to this bus, like this. And each computer system in a network is known as node. Suppose in this system there are 4 computer systems are connected to bus. Suppose it may be system A, system B, system C and system D. And the data transfer takes place through this bus only. Suppose system A wants to send a message to system D. It will send the message to the bus, and the bus carries the message over this. And the same message will reach at system B, system C and system D. So along with the message there will be a destination address. Now our intended destination is system D. So the message will carry the destination address of system D. So all other systems or all other nodes other than the intended destination will discard the message, and the intended destination will accept the message. The major drawback of bus topology is the chance of collision. Whenever two systems try to send the message at the same time, there happens some collision inside the bus since the bus carries the data. Also, addition of new nodes to this system may causes the loss of signal strength. Also, there is no security in message since this message reaches every other nodes along with the destination nodes. Besides all these drawbacks, there is some advantages also. Since it contains only single cable, the installation is very easy and the reconfiguration is also very easy, and it is very inexpensive also. So that's all about bus topology. Now let's see the next topology, that is star topology. In star topology, there is a centralized device known as hub or switch. We can use either hub or switch as a centralized device, and all other nodes is connected to this centralized device. As previous example, there are 4 systems we are connecting in this typical diagram, star topology diagram, that is system A, system B, system C and system D. So we are connecting 4 devices to the centralized device. The centralized device can be either hub or switch. So what will be the difference between hub and switch? In star topology, the data transfer takes place in such a way that the system sends the message to the centralized device, and centralized device transfer the message to the intended destination. Suppose system A wants to send a message to system C. The system A will send the message to the centralized device along with the destination address. and the centralized device will transfer this message to the system C. Okay. So, what is the difference between hub and switch? If the centralized device is a hub, the hub will broadcast the message to system D, system B and system C. Every other device will get the message. But we are using switch. If we are using the switch, switch will transfer the message from system A to a correct intended destination, that is system C. That means it will perform unique casting. That's a major difference between hub and switch. So, if we are using star topology, it is always better to use switch rather than hub, because switch is always an intelligent device which will transfer the message to the intended user based on the destination address. But the hub will broadcast the message to every other nodes along with the destination system. Now, let us say the advantages of star topology. If we are using switch as a centralized device, the chance of collision will be less because it can provide multi-way communication. At the same time, A sends a message to C, at the same time the B can send message to D. Multi-way communication is possible if we are using switch as a centralized device. The chance of collision will be reduced. Also, it is very inexpensive because it contains less number of cables. But it is expensive than the best topology because it has more cables rather than the best topology. Okay. Now, beside all these advantages, it has a certain disadvantage also or drawback also. If the centralized device fails, then the complete network will get collapsed. That's a major drawback of star topology. So far we have seen best topology as well as star topology, and this is all about star topology. Now let us see ring topology, thereafter we can see the mesh topology. Now let us see what is a ring topology. In ring topology, every device is connected to its adjacent devices. Each node or each system is connected to two other devices on its left side as well as on right side. Let us see an example like the previous one. We have four systems here, system A, system B, system C and system D. It is connected in such a way that system A is connected to system B as well as system D, because these are two adjacent devices to system A. Now system B is connected to system A as well as system C, and system C is connected to system B as well as system D, and system D is connected to its adjacent devices, that is system A and system C. But the interesting fact is that the data transfer will take place in unidirection or in one direction, that is in circular fashion. The data transfer will take place in circular fashion. Whenever system A sends a message to system D, it will move through this path. It will come to this system B, then the message will come to system C, then the message will reach us system D. And this is the path for data transfer. And from this figure, we can see that the chance of collision is lesser since the message travels in unidirection. But the security also is lesser because the message will reach every other devices before it reaches the destination. Besides the lack in network security, it also poses certain drawbacks, some other drawbacks. Like whenever the system fails, the entire system will collapse or entire network will collapse. Whenever system A or B or C or D collapse, then the entire network will collapse. And also reconfiguration is a tedious task. Means adding of new devices to this network or removing the existing devices from this network is a tedious task. That's all about ring topology. Now let's see what is a mesh topology. In mesh topology, every system is connected to every other devices in the network. Let's see an example. Now system A, system B, system C and system D. System A is connected to every other devices. System A is connected to system B, A is connected to C and A is connected to D. Now system B. B is connected to A, B is connected to C and B is connected to D. System C. C is connected to A, C is connected to B and C is connected to D. Now system D. D is connected to A, D is connected to B and D is connected to C. This is mesh topology, thus forming a mesh. Every device is connected to every other devices. Now we can see the number of links using a mathematical formula. Suppose number of nodes be n. N be the number of nodes or number of systems. Then the number of links in each device will be n minus 1. Okay, if n is the number of devices or n is the number of nodes in the network, then number of link in each device will be n minus 1. And total number of links in the network will be n into n minus 1 divided by 2. Look at this example. N will be the number of nodes. In this example, n is 4. Now, number of link in each device. So, number of link in A. Number of links in A device will be 4 minus 1, which is equal to 3. Let's see whether it is right or not. This is A. Number of links to A is A to B 1 link, A to C second link and A to D third link. So, number of links in A will be n minus 1 or 4 minus 1, that is 3. Now, number of links in B will be again 4 minus 1, which is equal to 3. So, this formula is satisfied. Now, let us see total number of links. In this example, the total number of links will be n into n minus 1 by 2, which is equal to 4 into 3 by 2, which is equal to 6. Let us see whether it is right or not. We can count total number of links 1, 2, 3, 4, 5 and 6. So, the formula is again satisfied. This is how we find out the total number of links and the total number of link in each device. If n is the node, then the number of links in each device will be n minus 1 and total number of links in the device will be n into n minus 1 by 2. Mesh topology is very expensive since it contains so many cables and also it is very difficult to reconfigure. But the very interesting fact is that if any of this link fails, the entire transmission will not fail and it finds some other alternative path to continue the transmission. For example, if A wants to send a message to C, the direct path A to C is broken. Okay, but the transmission will never stop. It will find some other alternative path like A to B then to C. This path or this path will get generated. So, the overall transmission will not get failed even if one link will fail. So, this is all about mesh topology, and so far we have seen different types of topologies: base, star, mesh and ring. Hope you all enjoyed the class. Stay safe and thank you.